Hi, I'm Kent Culbertson with American AVK. I'm here today with Randy Looney. Randy, welcome, and it's good to have you here. He's our Special Projects Manager. And how long have you been with AVK, Randy?
A bit over 27 years.
Man. Okay, so one of the more interesting things that I've noticed about you, the AWWA M17 manual, which is, you can talk a little bit about what it is, but acknowledges your contributions to the subcommittee and whatnot in the AWWA manual. Do you want to tell us a little bit about the subcommittee's work and the importance of the subcommittee's role?
Well, first of all, at AWWA, they have main committees that are focused on just a particular topic. So in other words, there'll be a main committee for valves, there'll be a main committee for hydrants, one for water tanks. Those main committees are divided into subcommittees, and the subcommittees are focused on one particular topic. For instance, a subcommittee for gate valves, a subcommittee for butterfly valves, or a subcommittee for ball valves. These subcommittees are required to be balanced by the AWWA, so 1/3 of the membership is producer or manufacturer, 1/3 is end user or consumer, and 1/3 is general interest members. The standards are endorsed by ANSI, which is the American National Standard Institute, and ANSI requires AWWA to review, revise, or update the standards at least every 5 years. So the subcommittee gets the assignment to revise the standard. Once the committee members agree on the changes and updates that they want to make, this is then turned over to the AWWA Standards Council. And then the Standards Council has to review it, make sure it follows all the guidelines and it's acceptable to what they want. From there, it goes back to ANSI. ANSI has a review period, and once it gets through the review period and is approved, then ANSI endorses the standard and it becomes an American national standard. Once we reach that point, then the standard's published.
Okay. Well, we appreciate all you do in that regard. I know you go out of your way. I've been to some of the meetings with you, and you've always given it 110%. Personally, you've been involved in over 70 improvements of the AVK dry barrel hydrant. So if you had to pick 3 of those top improvements you've made, what would they be?
I think the top one would be the hydroflow main valve. It is designed to eliminate water hammer when closing a hydrant. Water hammer occurs if the hydrant is closed too quickly and the main valve bounces onto the seat ring, and it causes a shock wave, travels back up the pipe, and can rupture the pipe if it finds a weak spot in the pipe. So when we develop the hydroflow main valve, what happens is, as the main valve is coming close to closure, the distance between the valve and the seat gets smaller and smaller. And just like you're putting your thumb over the end of a garden hose, when you restrict that opening, the velocity increases. So as that main valve is coming close to the seat ring, the velocity is increasing across the top of that main valve, and as the velocity increases, it pressure drops. We end up with a low pressure zone on top, and the water underneath can't get through that smaller opening, and so its velocity is slowing down. So we end up with a high pressure zone underneath, a low pressure zone on top, and that's what causes it to suddenly jump, hit the seat, and cause the water hammer. So when we developed the hydroflow main valve, what we did is we designed the top surface so that it tricks the water to form that low pressure zone sooner than it would in the closing sequence, so that the valve can still move, but it's far enough away from the seat it doesn't contact it, and you can safely close it and not cause the water hammer. So that one was a lot of fun. I think the second one would be the 5-bolt inlet base. Reduced our head loss and increased the water flow through the hydrant. And as we all know, the more water you can get through a hydrant, the more water you can put on a fire over a given time period, the faster you can put the fire out. An added feature was that it actually makes the hydrant easier to assemble in our factory. So that was kind of a bonus. I think another one would be the little anode lug that we added to the 5-bolt inlet base. That allows an installer to attach a grounding wire, so it helps prevent galvanic corrosion in active soils.
Yeah. I agree. Those are all good. Now, on the wet barrel hydrant, you've been personally involved in the FlowGuard 2 development. And have you always been interested, and I already know the answer to this, solving complex problems like that? And what are the features you're most proud of on the FlowGuard 2?
When we were developing and testing the prototype for the FlowGuard 2, we discovered that under certain water flow conditions that the rubber encapsulated sealing ball vibrated quite badly inside the housing. I mean, it was enough to shake the whole hydrant. And so we, figuring out the root cause and coming up with a solution to the problem was very challenging. But I find you get a big sense of satisfaction when you can solve a problem, put it in production, and the solution actually works.
Yeah, well, you did a great job. It's a great product. And then after 27 years, I mean, you come in here every day. What motivates you to help your teammates and help AVK grow?
Well, I think we can provide high-quality products to our customers that once they install them, they don't have to worry about them.
Yeah.
And that just makes everybody's job easier.
Yeah. Well, Randy, thank you so much for your time today. Again, really appreciate it. Love working with the guy, and I'm glad you were here today. So
Thank
that's
you.
it.